Good morning, grade 11 students. In this session, we're going to talk about the gene localization for the week 33 in the chapter of genetics. First, we determined we can identify using a pedigree or using the cross whether the allele is dominant or recessive, whether the allele it was masked in the parent or not. Also, we determined using the pedigree the different forms of the disease. We said that if it's autosomal or it's gonosomal, it's found on the autosomes or the gonosomes. In this session, we're going to move deeply to see if it's found on the chromosome X or it's found on the chromosome Y or it's found on both chromosomes X and Y, or if it's not found either on X or Y or X and Y, so it's autosomal. Before we start, let's move over these two notes. How to verify that the affected recessive allele, the allele of the disease is recessive. If we have two normal parents, and these normal parents, they have an affected child. So here we can verify that the allele is recessive for the disease. While to verify that the dominant allele is for the disease, to verify the affected dominant allele, you have to find two affected parents, they have a normal child. So the allele of the normal will be masked here. Here is the opposite. So here you have to pay attention. Always we worked on the allele of the disease is recessive with respect to the normal dominant allele. Sometimes it's not the case. Sometimes the allele of the disease is dominant, while the allele of the normal is recessive. And we are going to work on this in the coming session. Location of a gene. A gene, it has different locations. Either it can be autosomal. What the meaning of autosomal? It can be on the autosomes from chromosome number 1 to chromosome number 22, where it consists of two alleles for male and two alleles for the female. So allele, male and female, both of them, they have two alleles. It's autosomal. So they inherit one allele from the mother and one allele from the father. So one paternal and one maternal. This is if the case if the gene is autosomal. While in the second case, if it's found on the non-homologous part of Y. Wait a minute. Before we continue, always whenever you talk about the Y chromosome, you have to say the non-homologous. Non-homologous, they say sometimes non-homologous region, and sometimes they said non-homologous part. It's the same. Non-homologous part of Y. Which of the two sexes, male or female, they have the Y? Which of the two sexes, male or female, they have the Y chromosome? Yes. Let's see. About the pedigree and the cardiotype. Yes, Yusuf.
Main.
Male.
The male. The male has the XY. So if the allele of the disease is found on the Y, so we're going to write it as a power here. So for example, let's say we give the allele of the disease is D small. So here D small. Here it exists only in one copy. Even though it's recessive, it's found on the Y. So this person is said to be affected. This is the non-homologous part of Y. How would this individual inherit the Y? We will see. Or it may be found on the non-homologous part of X. Non-homologous part of X, maybe the male has XY and the female, it has X and X. So here the male, if it's found on the non-homologous part of X, it has one copy, it has one X, while the female, it will have two alleles. This it has two X's. And if it's found on the homologous part of X and Y, so it's found on both X and Y at the same time. But here, if you see, I said the homologous part of X and Y. So we have two alleles for the female, since it has, so for the male, sorry, since it have XY. So one allele will be on the X and the other will be on the Y. Or two alleles for the female, since it has two X's. So one allele on one X and the other will be on the second X. So here we have how many different possibilities? We have four possibilities. The first possibility, it can be autosomal. The second, it can be on the non-homologous part of X, or they say non-homologous region of X, or non-homologous part of X. Here, non-homologous part of Y. Three, non-homologous part of X. And number four, the homologous part of X and Y. So here we have four cases. How can we prove these cases? How can we prove one of them? And what should we do? In order to prove one, we have to deny the others. For example, they said that the allele of the disease is autosomal, it's found on chromosome number 7. So in order to prove that it's autosomal, and they said discuss logically the localization of the gene. If I want to say if it's autosomal, I can't say immediately it's autosomal. I have to deny the non-homologous part of Y, non-homologous part of X, and the homologous part of X and Y. I have to deny the three cases in order to reach to one of these cases. How can we deny this? How can we move step by step to verify this? You will see. Yeah. To verify that the gene is autosomal. This one, to verify that it's autosomal, all the individuals, males and the females, they have equal probability to be affected by the disease. For example, in the pedigree, we have 10 affected individuals. 5 of them should be males and 5 should be females, for example. Or to verify that the gene is located on the non-homologous part of Y. You have two cases and you have two solutions for this. The first solution is only males will be affected. Why? If the gene is found on the Y, on the non-homologous part of Y, so all of the females, they are going to be normal. Why? Because the females, they have XX. They don't have Y, so all of them, they should be normal. So this is one solution. If it's found on the non-homologous part of Y, all of the females, they should be normal. If one of the females is affected, so it's not the case. Or every affected son, we said that's found on the non-homologous part of Y. Imagine that the son has affected by the disease and has the genotype XYD. So this YD will be inherited from where? From his father. His father is also affected. But if his father is not affected, so it's not the case. So every affected son should have an affected father. If it's like this, so the gene is located on the non-homologous part of Y. If it's not like this, so this is not the case. So I will repeat. To verify that the gene is located on the non-homologous part of Y, what you have to do? Either you have to look at the pedigree, you have to say all the females, only females that are affected, and none of the females are affected, so this is the case. Or every affected son should have an affected father. Why? Because it's located on the Y, and the Y should be inherited from the father, and the X should be inherited from the mother. This YD, it carries the allele of the disease. So the father should have XYD also and should be affected. But if the father is normal, so this is not the case, and it's not located on the non-homologous region of Y. This is the first two cases. How to verify it's autosomal, and how to verify that the gene is located on the non-homologous part of Y. Non-homologous part of Y. Here, the non-homologous part of Y is very easy. If you look at the pedigree, if we have one female affected, so it's not the case, since it doesn't carry the Y. Why? Yes, Ran.
Can you repeat the autosomal gene?
Autosomal, I'm going to talk about it. Autosomal, to verify it autosomal, you have to deny Ran X, Y, and XY. This is theoretical. Here, I'm talking about theoretical. The male and female should have equal probability. But to be proven, you should deny the X, يعني لازم انفي X, non-homologous part of X, I have to deny the non-homologous part of I, and I have to deny the homologous part of X and Y. If I deny the three cases, then it will be autosomal. Okay? So I have to deny the three cases. That's why I'm going to talk about it at the end before you ask me the question. So autosomal, this is theoretical. But to be proven exactly according to the pedigree, you have to deny the three cases. Let's continue with the third. How to verify that the gene is located on the non-homologous part of X. If it's located on the non-homologous part of X, every affected daughter should have an affected father. Why? Affected daughter, it has XD, XD. The allele of disease is recessive also. Here I'm going to talk about the allele of disease is recessive. So it has XD, XD. So it should inherit, this affected daughter should inherit XD from each of her parents, from the father and the mother. So her father should have XDY. So XDY meaning that the father is affected. If the father is not affected, so it's not the case. Number four, how to verify that a gene is located on the homologous part of X and Y. X and Y, the homologous part of X and Y, the recessive daughter and the recessive son should have a recessive father. How? We will explain this exactly when we move to the pedigree in this application. In this application, we have 1, 2, and 1, 1 and 1, 2. They are normal. And also 2, 3, 2, 4, and 2, 5, also they are normal. So how to prove this and how to verify that, discuss the logically chromosomal location of the gene. What does this mean? Always you're going to see this, discuss logically, how discuss or verify the chromosomal localization or the location of the gene. And this, the white they are normal, and the blue they are affected. First of all, before I start with this, remember how can we solve the exercise before? Before I ask you, how can you deduce from this cross? Designate by symbol each of the corresponding alleles. Is the allele of the disease dominant or recessive? Designate by symbols. And then I told you to perform essential factorial analysis and so on. Here, if I ask you only this question, discuss logically the chromosomal localization. First, you have to say dominant or recessive. Which allele is dominant or recessive? This is first. You have to do so. Two, you have to give symbols. Three, you have to discuss the localization. So number three, the gene localization. So you have to determine whether the allele is dominant or recessive before you start. You have to give symbol for the allele of disease, and you have to give symbols for the normal, and then you have to start with the gene localization. So this question includes all the parts and all the questions that we have covered them before. So here you have to pay attention. Some of you in the quiz, what did they do? Some of you, they, for example, they gave a symbol for the disease, D small, and then in the third part, for example, or in the factorial analysis, they gave it the symbol A. So I crossed all the factorial analysis. Some of you, what did they do? Some of you, they substituted the male and the female, and I crossed about 80% of the part. I cross it because you don't know which one is the male and which one is the female. So you reverse that. So this inversion will lead to no mark. Here, also the symbols. Some of you, they didn't give symbol. How come you didn't give symbol? And then you are going to work with the symbol. And you say, and D, and D, D. How come? You didn't give symbol. So you are not able to use these unless you tell me. You says you know this. Yes, I know this. But I don't know that you understand this. You have to show me. That doesn't mean biology, doesn't mean that you know. I know, I use this. I know already this. No, you have to write these down. If you don't write these down, this means that you don't know. This means that you're going to lose your marks. And I'm going to be so strict from now on. Inversion of male and female, I will cross the whole exercise, meaning that the whole factorial analysis. not using the symbols or not verifying the symbol. For example, let n capital be the symbol of the normal allele, which is dominant over the recessive allele, kaza, and so on. So if you do use this, I'm going to cross the whole exercise. So from now on, you have to pay attention. This exercise is very critical, and the mark, either you got it or you don't. So you have to pay attention from the beginning. Maybe sometime you're going to, for example, you solve it by mistake, you said that it's autosomal, you verified autosomal and it's not autosomal. I will work according to your mistake, but if you did another mistake, I will cross the whole exercise. This is the case of math and physics, all is the same. يمشي على اساس الغلط. ترجع بغلط again, so it means that you're not understanding, you're not solving correctly. So you have to pay attention to these places. Here we go with the verification. First of all, I said that 1, 1, 1, 2, 2, 3, 2, 4, 2, 5, all of them till 2, 4, 2, 3, and 2, 4, they are normal. Don't wait to 2, 5. So first, 1, 1 and 1, 2, they are normal, but they gave birth to affected children, 2, 1 and 2, 2. So the allele of the disease is recessive with respect to the normal dominant allele. This is first, I determine the dominant and the recessive. Second, I move now to what? To the symbols. So I have to give the symbols. Let n capital be the symbol of the normal dominant allele, which is dominant over the recessive allele of the disease. And let C small and so on. So here I gave, since parents 1, 1 and 1, 2 are normal, and they gave birth to affected children 2, 1 and 2, 2. So the allele coding for the disease is recessive with respect to the normal dominant allele. And you can say here, and we can add it, and it's masked. Okay, you can add it if you want, and it's masked. Here I determine the dominant and the recessive. This is the first step. Second, I will give the symbols. Let n capital be the symbol of the normal dominant allele of the recessive allele of the disease, and let d small be the symbol of the allele of the disease, which is recessive with respect to the normal dominant allele. Let's start here to determine the gene localization. Who can deny it on the non-homologous part of Y? By raising your hand, please. Who can deny it on the non-homologous part of Y? مين فيها on the non-homologous part of Y?
أستاذ خطك عم بقطش.
Let's check your connection.
إنه كذا حدا صار قايل يا أستاذ
Please
على
mute
الجروب.
yourself. Please mute yourself. Thank you. So, let's discuss this. 1, 1 and 1, 2, they are normal, but they gave birth to 2, 1 and 2, 2. 2, 2, it's a female. So female is affected. So it has XX, doesn't have a Y. So this Y is not found in 2, 2. So this means that this girl is affected, but it doesn't carry the Y, so it's not found in the non-homologous part of Y. Here I deny it, since we said that if it's found in the non-homologous part of Y, none of the girls should be affected. So here we have 2, 2, it's affected. So it's not the case. Here I deny it on the Y. Let's deny it on the X. If it's on the X, this female, it has XD and XD. It's found on the X. So this female, it should inherit XD from the female, from the mother, and XD from the father. So this father will be XD Y. And this can be XD XN, let's say, if it's found on the non-homologous part of X. But if it's found on the X, this individual XDY will be affected. So this individual XDY will be affected, so this is not the case, since 1, 1 is normal. So here I deny it first. On the Y, we said first, since we have a female is affected, so it's not the case, so it's not found on the Y. Next, and the female, and the X, sorry, if it's found on the non-homologous part of X, every affected daughter should have an affected father. This here it has XD XD. It should inherit XD from the mother, from the maternal, and XD from the father, which is paternal. So here it's XDY. So here XDY should be affected. So it's not the case because 1 1 is normal. So here I deny it on the X and non-homologous part of X and the non-homologous part of Y. Third, I can move to 2, 2, 1, and 2, 2 to deny it on X and Y together. If the gene of the disease is found on the homologous part of X and Y. This 2, 1 is a male, so it has XY. And this one is a female, it has XX. Here, XX and XY. If it's found in the homologous part of X and Y, so here it should have XD, YD. And this individual, it has also XD, XD. So here it should inherit XD from the mother and XD from the father. So here it should have XD and the male should have XD. And here the male to 1, it has XD, YD. YD sure will inherit it from the father. So this is YD. And XD should be inherited from the mother. And this is XD. If it is the case, then 1 1 and 1 2, both of them will be affected, but they are normal. So it's not the case. So here I deny it on both non-homologous part of X, non-homologous part of Y, and also I deny it on the homologous part of X and Y. So here it is autosomal. So I denied the 3 cases again to move for the autosomal. And I already know that it's autosomal. And sometimes they mention this in the text. They told you that the gene of the disease is located on the chromosome number 7. Discuss logically the localization. And you have to know, you know that already it's found in the X. So here we denied X, Y, XY to go to the autosomal. Yes, Ran, your question is.
أستاذ لما أنت أول شي عملت ديناي قلت
Yes,
إنه على التوتو قلت
yes.
إنه هي الجيرل الوحيدة اللي رح تطلع affected وهي فعلا الجيرل الوحيدة اللي طلعت affected.
Wait a minute, wait a minute,
كيف ما
wait,
مش
wait a minute, wait a minute, wait a minute. I said مش قلت هي الجيرل الوحيدة اللي هتطلع affected. هي affected. So Tutu, it's affected. She's affected. Okay?
يعني مزبوطة
هي affected.
الديناي.
هي affected. يعني أنا عندي 1 1 2 1 و 2 2 they are affected in the pedigree. So 2 2 هي affected. So هي affected. So it's not found on the Y أكيد because none of the females should be affected. If you remember بس قلت هون أنا كيف فينا ننفيها on the non-homologous part of Y. Only the males will be affected. So no females. إذا كان عندي females so it's not the case. Okay رهن؟
أوكي
تمام؟
أوكي.
Okay. How deny it on the X? On the X, every affected son should have an affected father. But to one who affected, by one not affected. إذا هي على X. Okay? So هون X is if it's on the X, so هي XD Y. Here it has XD XD. So here من هياخد الواي من بيو أكيد. وهيدا هتاخد XD من أمها وXD من بيها. So هون هتكون XDY. هيدا البي هيكون affected but هو مش affected so it's not found on the X. Y it's found on X and Y. This is a male XY and this is XX. If it's on the X and Y homologous part of X and Y and the allele of disease is recessive. Pay attention here. Allele of disease is recessive. So here what do we do? If it's on the X and Y, here it's XDYD. And here it's XX, XD, XD. Hon XD from the mother will be, here it's XD, and here XD from the father. يعني هياخد XD from أمه, XD من بيه. And here YD sure من بيه. So this is YD, Y. This is Y, okay? This is YD. And this XD from the mother. So here, if it's an X and Y, homologous part of X and Y, both 1, 1 and 1, 2 should be affected, but it's not the case. So here I denied the three cases. The non-homologous part of Y, since we have a female affected. The non-homologous part of X, since every affected daughter should have affected father, but it's not the case. And the third case, we denied on X and Y, since we have and 1 and 2, 2, they are affected, and if they are affected on the X and Y, Bayun M1 should be affected, but it's not the case, and this is the autosomal. So here, first of all, as I said, بدنا نعرف مين dominant مين recessive. Second, we have to give the symbols of the allele. Third, we have to deny. So if the gene of the disease is located on the non-homologous part of Y, here I solve it in two ways, in two methods. But sure, in the exam, you use only one method. Don't use two. If the gene of the disease is located in the non-homologous part of Y, then none of the girls should be affected. Why? For the girl, they have XX, but 2, is affected. Please, you have to solve the way that I'm solving here. You have to use the same way because this will help you a lot during the exercises. So if the gene of the disease is located in the non-homologous part of Y, then none of the girls should be affected. But 2 is affected, so this is not the case. Or you can solve it in another way. Every affected son should have an affected father. But 2 is affected, it has XYD if it's on the Y. Should receive YD from his father, 1, who should be affected also. But from Pedigree, he seems to be normal. So this is not the case. Always, whenever they have to deny it on the non-homologous part of Y, they use this. They told me that this is simple, more than using this. So this is easier for you to work on. None of the girls should be affected, but 2 is affected, so it's not the case. Here we deny it on the non-homologous part of Y. Pay attention to write non-homologous part, since the X and Y, they are not the same. If the gene is located on the non-homologous part of X, every affected daughter should have an affected father. But female 2 is affected. It has XD. It should receive what? It should receive XD from father 1, who should be affected too. But from the pedigree, he seems to be normal. So it's not the case. So here we deny it on the non-homologous part of X and the non-homologous part of Y. Let's move now if the gene is located on the homologous part of X and Y together. So son 2, XDYD should receive YD from his father, and affected daughter 2, XD should receive XD from her father. So the father 1 should have XDYD and should be affected. But from the degree, he seems to be normal, so it's not the case. So here we deny it on the X, the non-homologous part of X, the non-homologous part of Y, and the homologous part of X and Y. Then the gene of the disease is said to be autosomal. So the gene of the disease is said to be autosomal. So I repeat, in order to get 1, you have to deny 3. So denying 3, you will get the 4th. So you can say immediately that is autosomal without denying the non-homologous part of X, the non-homologous part of Y, and the X and Y. So you have to deny all of these in order to reach the final answer. Also, maybe sometimes they are going to mention this in the text. Maybe they're not going to mention this in the text. So always start from the non-homologous part of Y, then move to the non-homologous part of X, then move to the X and Y. If you can deny all these, then it's autosomal. If you can deny one of them, then it's the case. So we're going to work about this over the time. Here, pay attention. My solution is based on the allele of disease is recessive here in this pedigree. Next session, we're going to specify the genotype of the members of the family. Since it's autosomal, so we don't write them neither on X or on Y. So 2, and 2, and 2, they are affected, DD, since they are affected by the disease and the allele of the disease is recessive. So it's expressed only in the pure state or homozygous. 2, and 2, and D. Why? They are normal, but they gave birth to infected children 2-1 and 2-2. So the allele of disease was masked in the parents. It's recessive with respect to the normal dominant allele. 2-3 and 2-4. 2-3 and 2-4. Here 2-3 and 2-4. 2-3 and 2-4, according to the pedigree, they can be either an N or an D. How can we determine this? I told you before. We have special techniques, or if they got married, we can determine if they gave birth to affected children, they will be sure ND. So they can be either an N or an D. بيجي مهدي بيسألني, for example, if in the exam I said only an N, it will be wrong or true. Sure, it will be wrong. So we have two possibilities, an N or an D. They may inherit N from each of the parents, or N from one parent and D from another parent, since they are normal and it can be expressed in both homozygous and heterozygous. Next session, we're going to move to this pedigree. This is somehow a complex pedigree compared to the pedigree that we started in this lecture.